All right. Got me working day and night. Oh yeah, so depending on where you started on this video, we are going to be looking, completing that, learning about simplifying square roots, to continue on from what we did in class today. So one thing to keep in mind, first, square rooting some real number, a squared, the actual square root is going to be the absolute value of a. Okay, so let me show you how this works. So for instance, after the square root of 9x squared, that is the same thing as the square root of 9 times the square root of x squared, which is 3 absolute value of x. Because if you notice, anything that you square is going to be positive. So that's why it is the absolute value of x. Okay, let's look at this one here, the square root of 25x cubed. I have the square root of 25 times the square root of x times x times x. All right, the square root of 25 we know is 5. Any pair, which is x times x, so anything multiplied by itself, or any number x multiplied by itself to give us x squared, the square root would have to be x, and then square root x. Okay, so go ahead and pause this video for a second and try to complete the last two there. So voila, you should have gotten 10 root x and then 5x cubed root x. All right. Now we're going to move on to adding and subtracting. So one thing to keep in mind, make sure the radicals are the same in order to add or subtract. If you don't notice they're the same, then go right ahead and try to simplify them if possible. So for the first one, pretty easy. So we have 2 root 5, take away 7 root 5, which will be negative 2 root 5. So I'm just subtracting those numbers in front of the radical, keeping it, just like combining like terms. Now, when I look at this one, it's not so simple. So root 12 is not simplified. So I'm going to go ahead and simplify this down. This is root 4 and root 3. So this is 4 from the 4 I got here times 2 root 3, which simplifies down to 8 root 3. Let me change up the color so you can see the other one. Root 75. So here I have 2 times root 25 times root 3, which would be 2 times 5 root 3, or 10 root 3. So overall, I can now subtract these two. I can subtract them because they are like radicals. So overall, this is negative 2 root 3. All right, how we doing? How we doing? Okay, next up, we have our product rule, which states that if I have product a times b, then I can take the square root of the factors of one of the factors a and the square root of the other factor and times that to the other factor b. Okay, so for instance, if I have root 8 times root 2, that's the same thing as the square root of 16, which is 4. Okay, quotient rule, if I have the square root of a over b, it's the same thing as the square root of a over the square root of b. So for instance, if I have root 50 over root 2, that is the same thing as the square root of 25, which is 5. Don't believe me? Test some numbers out. Create a proof. You can bring it to class. All right. Next up, if you notice, I kind of started this for you already. But if you take, I'm using the product rule here. If I multiply 3 and 15, I get 45x squared. And then, of course, x times x. And then if I simplify, I should get 3x root 5. Okay. The next one, I'm going to go ahead and use the quotient rule. This is equivalent to the square root of 48x cubed over 4x, which is equivalent to the square root of 12x squared. And we've done the square root of 12 before, so we kind of know that this is going to be 2x and then root 3 on the inside. Okay, go ahead and pause the video and try those other couple problems, and I will post those answers as soon as you restart the video. All right, so you should have gotten 2x root x and then x squared root 3. Again, if you're not getting that, definitely have those questions for me when you come back to class. And our grand finale thing to do is to rationalize the denominator. For some reason, we want to continue to rationalize the denominator. This is like a back in the day thing to help mathematicians who didn't have calculators be able to estimate pretty easily, as long as they didn't have a radical in the denominator. So we are going to continue to practice that because we won't be using calculators on our quiz. All right, so one thing you can do is always multiply the numerator and denominator by the radical to create a perfect square. So for this one here, I'm going to multiply the numerator and denominator by root 3. And notice this is 1, so I'm not changing the value. So this will be 7 root 3 over root 3 times root 3 is root 9. Therefore, this is 7 root 3 over 3. No more radical in the denominator. Woohoo! Easier to estimate now. All right, another way is you can multiply by the conjugate. Okay, the conjugate is pretty much, if you notice, it's like root A plus root B. The conjugate would be root A opposite of B. Okay, so you just want to kind of have that opposite somewhere so you can cancel out the radical. Okay, so for instance, I'm going to multiply by the conjugate of this here, which is going to be 4 plus root 3. Okay, and I need to do the same thing in the denominator. Okay, so when I multiply the conjugate, you're going to actually have to what we used to call FOIL, or now double distribute. So I'm going to put that work right over here. So 4 plus root 3 times 4 minus root 3. So when I FOIL this out, you're going to get 16 minus 4 root 3 plus 4 root 3. Okay, minus 3. That's okay. Got a little interruption, but it's okay. So this would end up being 13. Okay, so in my denominator, I have 13. And then in the numerator, we have 16. It's all right. It's Mr. Clayton. It's cool. Okay. This is 16 plus 4 root 3. And what do you notice? Nothing in the denominator. Woohoo! So go ahead, try those practice problems, and then bring them back, and we'll check them when you come back to class. Have a good weekend. Take care. I'm out.